Okay, hey everybody. So we have some notes today. The Pythagorean theorem inequality. Notes. Pythagorean theorem inequality. And it's not necessarily a section in the book, but it does deal with the Pythagorean theorem, and that's what we're learning about. So we are going to go over this. Now the inequality, the Pythagorean theorem inequality, it's used to classify triangles as acute, right, or obtuse. Okay, so an acute triangle, if it's going to be an acute triangle, the three side lengths satisfy this inequality. A squared plus b squared is greater than c squared. I like to think of it just this way. The c squared value is less than or smaller than the other side. So when this one is smaller, it's acute. Okay. When it's a right triangle, well, we've kind of already gone over this. A squared plus b squared equals c squared. So the c squared value equals the other side. And then if it's an obtuse triangle, we have the following inequality. The three side lengths satisfy this inequality. A squared plus b squared is less than c squared. Again, the way I like to make sense of it for obtuse is the c squared value is greater or bigger. So I think when c squared is bigger, think obtuse. When c squared equals, think right triangle. And then when the c squared is smaller or less, think acute. Okay, so pause this if you need to pause it. I'm going to flip it over and do some examples with you. So here we have some examples. So it's pretty straightforward. It's just you're going to be giving three side lengths or three measures, and the question is it an acute, right, or an obtuse triangle? Okay. If the numbers are not in order, just kind of always remember A has to be the small one, B the middle value, and then C the larger value. Okay. Then we're going to use the inequality. Now I'm going to leave this blank because I don't know if it's less than, greater, or equal yet. Okay, and then I'm going to simplify. I'm going to simplify everything. That's 25. That's 36. This is 49. Okay, I'm just going to keep bringing this guy down. That's 49. And then add 25 plus 36, and then you get 61. Okay. Well, I know 61 is bigger than 49, so it looks like this. Now, when this happens, or again, if you can't remember like the inequality, remember this. When C is smaller than these two, it's an acute triangle. When C is smaller, it's acute. Okay, we just had let that settle. This is the symbol we have on the other side, and that's acute. Okay. So let's do the next one. Again, A, B, C. If it's not in order, make A the smallest value, B the middle value, and C the largest value. Plug it into the inequality. 5 squared plus 10 squared equals c squared. And then again, I'm going to leave that blank for a second. And then I'm going to start to simplify this. 5 squared is 25. 10 squared is 100. 14 squared is 196, I believe. Yep, 196. Bring down to 196, and then add 25 and 100, and we get 125. Okay. Now in this case, this is the correct inequality symbol that should be in there. But again, go back to this is c squared. Whenever c squared is bigger than these two, you should think obtuse triangle. Okay, I didn't put remember that the inequality looks like that. I don't put anything in there because we don't know if it's less than, greater than, or equal. I know it's going to be one of those two. A squared plus b squared c squared. But again, whenever c squared is bigger than the other side, it's obtuse. Here c squared was smaller than the other side. That's acute. I'm pretty sure you can guess what the next one is going to be. This one should be equal if I chose the correct numbers. So let me go. That would be 8 squared plus 15 squared. Again, for now I'm going to leave this blank because I'm not truly sure. And then I know 8 squared is 64, 15 squared is 225, 17 squared is 289. Bring down the 289, add these two, 64 plus 225, and you get 289. And the two sides are equal, and then when they're equal, obviously that's a right triangle. Okay, and that's what we'll be doing today. Need to rewind it.